Our next section involves ratios and proportions. I think many of you have heard these words before, but we'll just do a little bit review just in case you forgot them or you've never seen them. So a ratio is a comparison of two quantities. So you often will see them written as something like 5:2:3. That's one way to write them. Or you'll sometimes see them with a colon in between, which is still pronounced 5:3. Or you'll also see it as something like 5/3. So all of these are examples of different ways to write a ratio. And if you have two ratios that are set equal to each other, that's what we call a proportion. So I'm actually going to give you an example of one. If you have x over 35 equals 4/7, you can actually solve this in order to figure out what that x is, because we know that these two fractions, these two ratios, are equal to each other. And you would find that if you were to try to figure out what the answer is, you can actually find that the answer for that is that x equals 20. And you'll find that that will give you a true statement, so that's an example of a proportion. So let's start with some ratio examples. So our first example it's fairly basic. It's probably something you've all seen before. So we know that there are 8 girls and 5 boys in a classroom. We want to find the ratio of girls to boys. So the ratio of girls to boys, there's 8 girls, 5 boys. You will write that just as 8:5. By the way, if you want, you can also write it with the word 2, T-O, or you can write it as 8/5. You do the same thing for the ratio of boys to girls. We know that that's 5:8. The only one that gets a little tricky is girls to the total number of students. The total number of students in that class is going to be 13, which you get by adding 8 and 5. So for that one, you would just do 8:13. Our next problem is one of those ones that looks easy, but is actually a little bit tricky. So there's 2 methods that you can use to do this. So the first method I'm going to show you, we are going to start, and actually you also do that for the second, you start by setting up a proportion. So for the first one, we know that the ratio of boys to girls is 5:8. There are 10 boys in the class. How many students are in the class total? So what you can do is, you know that for every 5 boys, there are 8 girls, so you can write that as a fraction. That's going to be equal to 10 boys over a variable, I'm going to call it g, which is the number of girls. So then there are several ways that you can solve this problem. One way you might really like to do it that I'll show you is you can take this 5, you know that to get from 5 to 10, you would have to multiply by 2. In order to find the number of girls, you actually are going to do the same thing to 8. You multiply that by 2, and you get there are 16 girls. Now, I said this problem was tricky. It is tricky. So that is not the answer. They didn't ask how many girls are in the class total, they asked how many students are in the class total. So in order to find the total number of students, you would add the girls, which are 16, there's 16 of them, plus the 10 boys that you already knew about. You get a total of 26 students. So now for method 2, rather than messing around with finding all the girls, this actually is a shorter method that you can use. You might like this better for that reason. So rather than knowing that the ratio of boys to girls in the class is 5:8, I know that the ratio of boys to students in the class is 5:13. I get that 13 by adding 5 plus 8. So for every 5 for every 13 students, 5 of them are boys. That's what we're showing here. So what you can do is you can say that that equals 10 over, I'm going to call the number of students S, and from there you can actually use the same process. So we know that to get from 5 to 10, you would have to multiply by 2. To get from 13 to S, in order to keep that fraction balanced, you have to also multiply by 2. So you're going to get that this S is going to be equal to 26 students. So either way will work. It's your choice which one you want to use for that problem. Our next set of examples, I'm actually going to give you a bunch of proportions. We are going to solve these using the cross product. So for this type of problem, there's actually many ways that you can solve it. You might find that you prefer doing one way over the other, but I'm going to do it using the cross product. So in order to do the cross product, what you're going to do is you're going to start with 4 times 5. 4 times 5, you can write your answer right here. Then you do 2 times x. You write your answer right there. You put an equals sign in the middle. Then you solve this using what you know about solving equations. And you get that your answer is x equals 10. So here's one I want you to try on your own. I have 4 over n equals 6 over 15. See if you can do this one using the method on the previous step. So if you did this, you should get that 4 times 15, that gives you 60. You get that that equals to 6 times n, which is just 6n. Then you're going to divide both sides by 6, and you get n equals 10. So here's another problem that's a little bit harder because we're going to add an extra variable in. So I have 5 over x equals 3 over x minus 4. I am going to use the same process as I did in the previous problem. The only difference now is that there's more variables that I have to worry about. So what I recommend is that whenever you see more than just one thing, you have 2 terms here, put some parentheses around it. It will make the problem a lot easier because you will not forget an important step, which is to distribute. So we're going to start with 5 times the quantity x minus 4. So now be careful that you don't just put 5x minus 4 with no parentheses. Very important that you don't miss that. We're also going to put 3 times x, and then stick your equals sign in between. So for the rest of this problem, you are going to solve this one using the same type of stuff that you did in the previous lesson, which had 2 variables on both sides. So first thing we're going to do is use the distributive property. That gives you 5x minus 20 equals 3x. Then you would subtract 5x from both sides. You get negative 20 equals negative 2x. And your final answer is x equals 10. By the way, it's just a coincidence that all 3 of these are equal to 10. It happened completely randomly. So for number 6, I would like you to see if you can do this problem on your own. I have 3 over x equals 2 over x minus 6. Please go ahead and pause. Give it a try. So to do this one, first thing I would do would be to put my parentheses around the x minus 6. I'm going to go ahead and do 3 times x minus 6. And I'm also going to do 2 times x. put my equal sign in the middle. Now I solve this using things that I've already learned. I distribute my 3. That gives me 3x minus 18. Now I subtract 3x from both sides. I end up getting negative 18 equals negative 1x or negative x. In order to get rid of that negative, I must divide both sides by 1. So my answer for that one is x equals positive 18.